All right, welcome back, everyone, to the deep dive. Today we're going to be looking into something that's kind of a hidden world, but it's something that affects every single file on your computer.
Yeah, it really is kind of a behind-the-scenes thing that most people don't ever have to think about, but it's there. It's working all the time, and that's file attributes.
Yeah, file attributes. And, we're going to be talking about, how these file attributes control the behavior of files and directories on our computers. We're going to be looking at different file systems, from Windows NTFS to ext4 in Linux to, even older systems like FAT.
Right, and the really fascinating thing is that, um, you know, we're used to thinking about, file names and date and permissions and things like that, but file attributes are a whole other layer of metadata that specifically control how these files behave within the file system itself.
And the really interesting thing is how different these file attributes can be, depending on what file system you're using. So, let's kick things off by going way back. I mean, way, way back to the days of DOS and early Windows. Even if you've never used DOS directly, its legacy, it's still kind of felt in a way.
Oh, absolutely.
So, back then we had these four core attributes that were kind of like the foundation of this whole system. And, the first one was archive or A.
Right.
What can you tell us about this seemingly simple little flag?
Well, the archive attributes is really all about backups, right? So when a file was created or changed this A flag, this archive flag would be set. And then backup software would look at this flag to figure out which files needed to be included in the next backup.
Okay.
And then after a full or an incremental backup, the backup software would usually clear that flag.
Okay.
Now it's interesting differential backups, which only save the changes since the last full backup. They usually don't clear the archive bit, so it sort of acts as an ongoing marker of change. At Stonefly, we've been pioneering SAN technology for over 2 decades. And we understand that these basic mechanisms, they're really the foundation of data protection, even in today's much more sophisticated storage solutions. You can learn more about our history, by the way, at stonefly.com.
So, next we have hidden, or H. This one seems pretty self-explanatory, right? It hides files, makes them invisible.
Yeah, pretty much. Setting the hidden attribute basically tells the operating system, hey, when you're showing files in a standard file browser or in a directory listing, don't show these files by default, right? So it's more about, keeping things tidy and preventing accidental modification than it is about any real serious security. Because, anyone who knows what they're doing can easily just tell the system to show hidden files.
Right.
So it's not really a foolproof security measure.
Okay, so then we have system or S's, and this one sounds like it's reserved for, the really important operating system stuff.
Yeah, you're absolutely right. The system attribute, that's for marking files that are absolutely essential for the computer to, boot up and run correctly. And these files are, they're hidden even more deeply than just hidden files, right? So even if you've told your system, hey, show me the hidden files, you usually need to take an extra step to actually reveal system files. And that really emphasizes just how important they are and how much trouble you can get into if you accidentally mess with them.
Yeah, it's not something you want to be, just messing around with.
No, definitely not.
Unless you, really know what you're doing. And, for a company like Stonefly that's been, delivering data management solutions for over 20 years, understanding these kind of system level protections, that's absolutely essential.
Oh, absolutely.
For building robust and reliable storage environments. And if you want to learn more about what we do, you can visit stonefly.com.
Yeah.
Okay, so the last one of these, original four, is read only or R. And I'm guessing this one means, you can open a file, you can look at it, you can read it, but it can't easily change it.
That's the basic idea, yeah. The read-only attribute, it's meant to prevent accidental changes. So when a file is marked as read-only most applications, when they open that file, they're not supposed to let you save any changes back to it unless you specifically request write access or something like that.
Okay.
But, it's worth noting that the behavior of this attribute, it can be a little bit inconsistent, especially when it comes to folders. Sometimes it's used a little differently by the system.
Gotcha. Okay, so those are like the fundamental four. But, as Windows evolved, especially when they introduced the NTFS file system, the number of attributes, it really expanded a lot.
Yeah.
So what was the reason for all these new attributes? What drove that expansion, do you think?
Well, the move to NTFS really came about because people needed more sophisticated file management, right? They were dealing with, more and more data, more complex needs. And so, one of the attributes that came along was compressed, or C. And this allowed Windows to automatically compress the data in a file when it was stored on the disk, which of course saves space. And, nowadays, modern storage solutions like the kind we offer at Stonefly, we handle this kind of compression at a much deeper level, but the attribute itself is still there to signal that, hey, this file is using that feature, that compression feature.
Interesting. And then, of course, we got encrypted, or E, for, protecting sensitive information.
Right, exactly. So when you set the encrypted attribute on an NTFS file, Windows encrypts the contents of the file so that anyone who's not authorized can't read it. And, Stonefly is a pioneer in SAN technology. We understand how important this kind of granular security is. Even though it's managed by the operating system, it's a crucial part of a good data protection strategy. And if you're interested in learning more about our security-focused solutions, you can find them on our website at stonefly.com.
Okay, cool. And then there's not content indexed I. So I'm guessing this has to do with making searches faster?
Yeah, that's it. So if you set the non-content indexed attribute on a file or a directory, you're basically telling Windows Search, hey, don't bother looking at this file. Don't include it in the search index.
Right.
And this can actually be really useful for files that, you're never going to need to search for by their content, like, some system files or something like that.
Right.
So it can actually help improve the performance of search.
Then there's directory marked with a D, which is just the system's way of, knowing that, hey, this is a folder.
Yeah, exactly. It's a very simple marker. It just distinguishes folders from regular files so the system knows how to handle them.
Okay, now we'll parse point L. That one sounds a little bit more complicated. What's that all about?
So a reparse point is basically a special kind of file or directory that contains a link to another location in the file system, but it's more than just a simple shortcut.
Okay.
When the system encounters a reparse point, it basically has to repart the path, figure out where it's actually supposed to go. And this can trigger some more complex actions like, symbolic links or junctions. Those are common examples of reparse points. And this idea of redirection and virtualization, it's something that, we've been using at Stonefly in our storage virtualization technologies for a long time.
Oh, wow.
So if you want to learn more about that, you can visit stonefly.com.
Okay, and then we have offline with an O. So I assume this means that a file is, not immediately accessible.
Yeah, the offline attribute, it's used in hierarchical storage management systems. So these are systems where, you might have data that's not accessed very often. And that data might be moved to a secondary storage system, something that's slower but cheaper. And the offline attribute basically tells you that, hey, this file's data, it's been moved. It might take a little while to get it back if you actually need to access it.
Okay, that makes sense. Sparse P, that sounds like it has something to do with, saving space.
You got it. A sparse file is basically a file where a lot of it might just be zeros. Empty space, right? And so to save disk space, the file system could be smart and just not actually allocate physical storage for all those empty sections. And so the sparse attribute just marks these kinds of optimized files.
So it's kind of like a placeholder in a way.
Yeah, in a way you could think of it like that.
And then lastly, we have temporary T, which I'm guessing is for files that, an application might create and then delete pretty quickly.
Exactly. So the temporary attribute often suggests that a file's probably going to be deleted soon. And so the operating system might treat it a little differently when it comes to, caching or cleanup procedures.
Okay, so we've got all these attributes in Windows, especially with NTFS. So how do you actually manage them? How do you go in there and change them or view them?
Well, in the old days, back in DOS and early Windows, you'd use the attrib command at the command prompt. That was the main tool for, viewing and modifying those basic 4 attributes: the archive, hidden, system, and read-only attributes. But nowadays, in modern Windows, File Explorer can actually show you some of the new attributes in the file properties. But for safety reasons, it's kind of limited. Like, for example, you can't directly change the system attribute through File Explorer. You'd have to use other tools for that.
So what about newer versions of Windows, like, say, Windows 7 and later?
So starting with Windows 7, PowerShell came along and it brought some much more powerful tools for managing these attributes. You can use the getItemPropertySetLit to read the attributes of a file or a directory. And then you can use the setItemPropertySetLit to actually change them.
Interesting.
So that gives you a lot more control over these settings.
And, I would imagine that you need certain permissions to be able to actually make these changes.
Oh, absolutely. On Windows NT-based systems, which, is pretty much all modern Windows versions, you need very specific file system permissions. You need the right attributes permission, and you need the right extended attributes permission to actually be able to modify these properties. And this is really important because it prevents, just anyone from being able to change the behavior of files in this way. It ensures that only authorized users or processes can make these changes. And, at Stonefly, we've been focusing on data management for over 2 decades. And we know how crucial these permission controls are. They're absolutely vital for maintaining data integrity and security, especially in storage environments. You can find out more about Stonefly and our solutions at stonefly.com.
That's fascinating. Now, let's shift gears a little bit and talk about the world of Unix and POSIX-like systems, because they have a bit of a different approach to managing file behavior.
Yeah, in Unix-based systems, they have this concept of a file mode. And the mode, it's not just about attributes in the Windows sense, it's also about the permissions, the read, write, execute permissions for the owner of the file, for the group that's associated with the file, and for everyone else.
Okay.
And it also includes special bits like, setDidism, setgid, and the sticky bit, which control certain execution privileges and directory behavior. But on top of all that, the mode also defines the type of the file itself. So whether it's a regular file or a directory or a special device file.
So it's like a more, holistic concept than just attributes as we've been talking about them so far.
Exactly, yeah. It's much more encompassing. But beyond those standard POSIX permissions, systems that are descended from 4.4 BSD, they introduce these specific file attributes that are often called flags. And these flags were categorized into user flags, which could be set by the owner of the file or by the superuser, and system flags, which should only be modified by the superuser. So you have this, kind of a layered approach to control, which is pretty interesting.
Okay, let's dive into those user flags a little bit. What were some of the key ones that were introduced in 4.4 BSD?
Well, there were 4 main user flags. First, you had no dump, which basically meant that the file or the directory should not be backed up. It's kind of the opposite of the Windows archive bit in a way.
Okay.
Then there was immutable, which was a really powerful flag. When you set this flag on a file, you couldn't change it at all. You couldn't write to it. If it was a directory, you couldn't create files in it. You couldn't delete files from it. You couldn't rename it. You couldn't delete it. Nothing. It was completely locked down.
So it's like the ultimate protection.
Yeah, for critical data, it's a very useful flag.
What about the other two?
Okay, so the third one was append only, which, as you might guess, it only allows you to add new data to the end of the file. You can't go back and change existing content. You can't delete anything. You can only append.
Okay.
And then the last user flag that was introduced in 4.4 BSD was opaque. And this one applied to directories, specifically in the context of union mount file systems. And basically, it made the directory's contents hide or mask any underlying directories in the union stack. So it was kind of a way to control the visibility of files in these more complex file system setups.
Interesting. And then what about the system flags? Those were the ones that only the superuser could change, right?
That's right, yeah. And initially, there were only 2 system flags, and they basically mirrored the user flags that we just talked about, immutable and append only. And setting these flags at the system level basically meant that even the owner of the file couldn't override them, right? So it's a way for the administrator, the superuser, to say, hey, this is really important. This file needs to be protected no matter what. And, that really reflects the Unix philosophy of giving a lot of power to the administrator to maintain system integrity. And, at Stonefly, we've been designing enterprise-level storage solutions for over 20 years, and we understand how important it is to have these kinds of really strong protection mechanisms in place. Our website is stonefly.com if you want to check us out.
So it's interesting, how they have that separation between the user-level controls and the system-level controls for basically the same attributes. But, other BSD-based systems like FreeBSD and Dragonfly BSD, they kind of expanded on these flags even further, right?
Yeah, they did. Both FreeBSD and Dragonfly BSD added this flag called no unlink. And this could be set by both the user and the system. And what it did was it prevented a file or a directory from being renamed or removed.
Okay.
Which is another, pretty significant level of protection against accidental deletion or, malicious deletion.
Yeah, definitely. And I know FreeBSD added a couple of their own unique flags, right?
They did, yeah. FreeBSD added this flag called no archive. And this was a system-level flag. And it basically meant that a file or directory should not be included in any archival processes, which is, it's different from the no dump flag, which is about backups. No archive is specifically about archiving.
Okay.
They also added a flag called snapshot, which was a system-managed attribute. And it was used to identify files that were part of a file system snapshot. And, this flag couldn't be manually set, even by the superuser, because it was really meant for, system-level management of these snapshots. And, Stonefly, we've been in the business of data integrity and recovery for a long time. You can check us out at stonefly.com. And understanding these snapshotting mechanisms is, absolutely crucial for what we do.
Yeah, that makes sense. And Dragonfly BSD, they had their own set of flags that they contributed to this, evolving world of file attributes too, right?
They did, yeah. Dragonfly BSD, they introduced the no history flag. And this flag, if the file system supported it, it would disable the recording of modifications to a file.
Okay.
They also had these two swap caches flag. So there was a user-level swap caches flag, which basically hinted to the system that, hey, it might be good to cache clean data from this file in swap space on an SSD.
Okay.
And then there was the opposite, the system-level swap cache flag, which would prevent this kind of caching. And then lastly, Dragonfly BSD also had an archived flag, which, we've seen in other systems as well.
Yeah, it seems like that archived concept kind of keeps popping up in different Unix-like systems. I know NetBSD and OpenBSD, they also adopted that flag, right?
Yeah, both NetBSD and OpenBSD, they added their own system-level archived flag, which kind of shows you how useful it is to have a flag. They just said, hey, this file has been archived or, needs to be archived. It's just a good way to manage data in the long term.
Yeah, that makes sense. And what about macOS, Apple's Unix-based operating system? How do they handle file attributes?
So macOS, they have their own set of flags as well. They have a hidden flag, which is a user-level flag. And just like in Windows, this makes the files not visible by default in the Finder. But you can still see them if you use command line tools, like the ls command. Then they have a restricted flag, which is a system-level flag, and that's part of their system integrity protection. It adds this extra layer of security. It prevents unauthorized modifications to critical system files. And then lastly, they have a compressed flag, which can be set by both users and the system, but it's a read-only flag and just indicates that files have been compressed using this older HFS plus compression technology.
Okay, so how do you actually work with these flags and attributes in, the Unix and BSD world?
So the main tool is the flags command. That's what you use to change or modify these flags. And to view them, you usually use the ls command. But you have to use certain options with ls to tell it to actually display the attribute information.
Gotcha.
And just like with file permissions, there are rules about who can change these flags. So in general, a regular user, they can modify the user flags on files that they own, or if they have superuser privileges, they can change anything. But the system flags, those can almost always only be changed by the superuser.
Okay.
And that's a really important part of how Unix security works. Stonefly, we have a lot of experience in secure data storage. And we get that. We understand why those granular controls are so important. You can learn more about Stonefly at stonefly.com.
It's amazing how many different approaches there are to managing file behavior, at this really fundamental level across all these different operating systems. But let's move on to Linux now, because Linux is known for, being very flexible and configurable. So how does Linux deal with file attributes?
Well, Linux actually provides a really rich set of file attributes, and you can manage them using the allsat command to view them and the chat command to modify them. And on top of that, programs can also interact with these attributes at a much lower level using something called the iofdel system call. So that gives developers a lot of power to fine-tune how files are handled by the system.
Yeah, it sounds like it. It sounds like it gives you a lot of control. Are all these attributes supported by every single Linux file system, though?
That's a good question. And it's important to remember that while you can try to set any attribute using Chattree, not every file system is actually going to support it. Common file systems like X4, XFS, and BTSFs, they support a lot of these attributes.
Okay.
But the exact set can be different from one file system to another. And if you try to set an attribute that's not supported, you're usually just going to get an error.
Right.
So you really do need to be aware of, what the specific file system you're working with can actually handle. And Stonefly, we've supported a wide range of file systems in our storage solutions for over 20 years. We've had to deal with all these little differences between them. And that's given us a lot of expertise in this area. You can check out our solutions at stonefly.com.
So what are some of the more common, or the more useful Linux attributes that, users or administrators should know about?
Well, one that's really practical is the no @sign updates attribute. And you usually set this with the flag A or, plus A to set it and A to unset it. And when this attribute is set, the file's access time doesn't get updated every time you read or access the file. And that can actually lead to some pretty significant performance improvements, especially if you have systems where files are accessed a lot, because it reduces the number of times the system has to actually write data back to the storage device.
Yeah, that makes a lot of sense, especially for, read-heavy workloads. What other attributes are there?
There's the append-only attribute, which uses the flag A. And just like we've seen in other Unix-like systems, this attribute means that you can only add new data to the end of a file. You can't change existing content. You can't delete anything. You can only append. And this is really, really useful for things like log files, where you want to make sure that the data is always appended and never modified or deleted. It helps with auditing and security.
Yeah, that makes a lot of sense. And what about immutable? I think that uses the flag I. And that also sounds like a really powerful way to protect data.
It is, yeah. The immutable attribute in Linux, it's very strong. When you set this attribute, you basically prevent almost any modification to the file. Not just the content of the file, but also the metadata, the information about the file. So you can't write to it, you can't delete it, you can't rename it, you can't even create a hard link to it. It's locked down tight. And, for a company like Stonefly, which you can find at stonefly.com, providing these kinds of data protection options is something we take very seriously. It's a key part of our philosophy.
Right. And we also see this no dump attribute, which I think uses the flag I. And that seems to be, pretty consistent with what we've seen in the BSD world as well.
Yeah, it is the no dump attribute. It basically just tells the old dump backup program, which is still used in some places, to skip that file or directory when it's doing its backup.
Okay. Then there's secure deletion, which uses the flag S. And that one sounds like it's all about, making sure that deleted data is actually gone.
Yeah, that's exactly what it's about. When you set the secure deletion attribute on a file, the system will try to overwrite all the backups on the disk that were used by that file. It overwrites them with zeros when the file is deleted. So that makes it much harder for someone to recover that data later on. It's a good way to protect sensitive information.
Yeah, definitely. And lastly, there's synchronous updates, which I believe uses the flag S's. What does that one do?
So the synchronous updates attribute, what it does is it forces any changes you make to a file to be written directly to the storage device right away before the system considers that write operation finished. So it's kind of like using the sync mount option, but it only applies to the files that have this attribute set. And it can make things a little bit slower, but it also makes sure that your data is always consistent and up to date on the disk.
Yeah, so it's a trade-off between speed and safety. So, as an expert from Stonefly, and we've been providing storage solutions for over 2 decades, how do all these Linux file attributes, how do they fit into the bigger picture of data management?
Well, the flexibility and the control that you get with Linux file attributes is really valuable in so many different server and storage environments. And at Stonefly, we've been taking advantage of this for over 20 years. It lets us really fine-tune our data management capabilities. So, for example, we can use a no-time attribute to improve performance. We can use immutable and append-only attributes to guarantee data integrity and security. And our SAN technology, it's designed to work with all these different file systems, including the ones you find in Linux. And it can take advantage of these attributes to provide our customers with, really optimized and reliable data handling. So if you're interested in learning more about how our solutions can actually use these features to meet your specific needs, maybe you have a very specific data management challenge you're trying to solve, please reach out to us at sales@stonefly.com. We'd be happy to talk to you.
It's really amazing how much thought goes into all these, these little details that most people never even see. Let's talk a little bit about Open Solaris and its derivatives. So things like Oracle Solaris and the Illumis project, because they have their own approach to file attributes as well, right?
They do, yeah. So back in 2007, Open Solaris introduced this concept of system attributes. And these were different from the more general extended attributes that you might find in other systems. And they were added mainly to improve support for CIFS, the Common Internet File System, which is the file system that Windows uses. So it was all about making these Solaris systems work better with Windows environments.
Okay.
And these new system attributes, they can be managed using the same command line tools that people were already familiar with in Unix.
Right.
So you could set a lot of these attributes, use the chmod command, and you could see them listed using the else command, usually with some specific options. And then, if you're a programmer and you're writing an application that needs to interact with these attributes, you would use the getAttrat and setAttrat function. So it was all designed to be pretty easy to work with.
And I think the ZFS file system, which originally came from Solaris, it has really good support for these system attributes, right?
It does, yeah. ZFS supports all the system attributes that are defined. And then later on in Oracle Solaris 11.2, they added support for some of these attributes to the TFSI file system as well. which is a file system that's stored in memory. So you can see how, these features were gradually being integrated into different parts of the Solaris ecosystem.
Okay, so what are some of the more common or the more important Open Solaris or Illumis file attributes that people might run into?
Well, you have the append-only attribute, which uses the flag I, and that's pretty much the same as the append-only attribute we've talked about in other Unix-like systems. You can only append data to the end of the file.
Okay.
There's also the immutable attribute, which uses the flag I, and this one's similar to what we've seen before. It prevents most modifications to the file. But one difference is that it usually still lets you change the file's access time. So it's not quite as strict as the immutable attribute in some other systems.
Right.
And then there's no dump, which uses the flag D. And as you might guess, that one tells backup programs to skip the file. And then finally, there's noun link, which uses the flag U, and that prevents you from deleting the file or unlinking it from the file system. But you can still change its contents or other metadata, so it's kind of a more specific protection mechanism.
Yeah, interesting. So, as an engineer at Stonefly, and we've been in the storage industry for a long time,
Mm-hmm.
what are your thoughts on the introduction of these system attributes and how they've evolved in systems like Open Solaris?
Well, I think it shows that, people are always looking for new ways to manage data. And these system attributes, they give administrators more fine-grained control. And they help make these systems more interoperable, so that Solaris systems can work better with Windows systems, for example. And at Stonefly, we've been a solution company for over 2 decades. And we've seen firsthand how these advancements have led to more versatile storage solutions that can integrate with all these different operating systems. And, we're always evaluating these new technologies, making sure that our own SAN technology is at the forefront of the industry. That's how we make sure we're providing the best possible solutions for our customers. And if you'd like to learn more about how Stonefly can help you with your cross-platform storage need, please don't hesitate to contact us at sales@stonefly.com.
Well, this has been a really fascinating journey, and we've delved into this kind of hidden world of file attributes, and we've seen how they work across all these different operating systems. So, as we wrap things up, what would you say is the key takeaway for our listeners?
I think the main thing to remember is that file attributes are really important. They might not be something you think about every day, but they're there, and they're controlling how files and directories behave on your system. And it's really interesting to see how different operating systems handle these attributes. Windows, macOS, Linux, the BSDs, they all have their own approaches. And those differences really reflect, the design philosophies of those systems.
Yeah, and why should our listeners, even if they're not system administrators or developers, why should they care about this?
Because understanding these attributes can actually help you do things like, manage your files better, like hiding sensitive files or making sure your backups are working correctly. It can also help you understand some of the more advanced things that system administrators do, like how they protect critical files from being changed accidentally, or how they optimize storage and performance. And just knowing that these attributes are there, it can help you troubleshoot problems. If something strange is happening with a file, it might be because of a file attribute.
That's a really good point. So, as we close out this deep dive, here's something to think about. Think about all the files that you use every day, all your documents, your pictures, your music, all of that, and think about which of these attributes might be working behind the scenes. Controlling how you access those files, how you change,